Scientific notation is used to express either very large or very small numbers with exponents. It can be used really for any type of number, but that's its main purpose. In recording scientific notation, it's going to be important to keep the correct number of sig figs to represent our correct measurement capabilities for the number that we're recording, which means we don't need to write insignificant zeros. Before we get into recording sig figs, or putting numbers into or out of scientific notation, we're going to break down the general format. So any scientific notation number should have a digit, a decimal, and then depending on the number you have, the remaining numbers. So we would have our decimal point here after the first non-zero digit. And again, this must be a non-zero digit. Specifically only one. And then this would be the remainder of our sig figs for whatever amount of sig figs we want to have. It is possible that you won't need the decimal and other numbers if you want only one sig fig. So we would put remaining sig figs here. Then we would add the scientific part. So that would be times 10 to some number, which is our exponent, needed to get our number back into standard notation or know how big or small that number happens to be. So we're going to call the exponent kind of space moves. This is the proper format. Sometimes people will try to write scientific like this. This would be considered incorrect because, again, the digit for the decimal should be right here, not further out. So let's look at the two types of numbers we have. Now, there's other ways you can think about scientific notation. This is just the way that I've found to make sense to my brain. Essentially, for scientific notation, I like to think of if the number should be big or small. So if I have a number that is larger than 1, the exponent will be positive. So what this means is any number that's over 1, think about it like money. If it's more than $1, it would have a positive exponent, regardless of if it's, $7 billion or not. Positive exponent because it's over 1. So that when I make the number or when I put it in scientific notation, I know that those two things have to be true. If I'm looking at an exponent and it's positive, I know that I have to make a number that doesn't have any leading zeros in it. If I know that the number is or over $1, that means that the number can't have a negative exponent. Again, this is just the way that makes sense to know how to move the numbers for me, but whatever makes sense for you, if you've learned a different way, that's totally fine. So looking here at this first example, we have 5.3, and then 10 to the third tells us there's that many space moves. So the original decimal from this scientific number is here. I want to move it 1, 2, 3. So that's 5, 3, and then wherever there are no existing numbers that you're moving past, those become zeros. Important to note that this number only has 2 sig figs, so I am not putting a decimal here. I'm going to get rid of that because I want to keep 2 sig figs, and with a decimal it would be 4 sig figs, so I'm keeping that true. The next example here is a 14 space moves. So one way you can kind of do this if you're more math minded is I can see here that there's 2 numbers already. So I got to get past those 2, which would leave me with 12 space moves, which means I need a total of 12 more zeros. So instead of doing this little like swoosh thing, I'm just going to go ahead and do that. 1, 1, 0, and then 12 zeros. 3, 6, 9, 12th. Now this number is a little tricky because you'll notice that the original number had 3 sig figs, but there is no way for me to make 3 sig figs in the standard notation version of this number, because the only place I could put a decimal is at the end, which would give me 15 sig figs, which is not what I want. So there are going to be instances where the only way you can get the sig figs you need is in scientific notation. So if you're taking a number out of scientific notation and you can't keep the sig figs, that's okay. But you should always be able to keep sig figs when you're putting a number into scientific notation. So again, looking now at the opposite way, I have all these numbers that I can clearly see are over 1, so they'd be more than $1. I want to put them into scientific, which means they should have positive exponents. When we do this, we need to think about, okay, where would the decimal, if there was one, because none of these numbers have decimal, where would the kind of phantom decimal be? And so in the case of all of these, if there was a decimal, it would be at the end. So I need to figure out, based on where I'm going to put my new decimal, how many space moves apart those are. So my new decimal would be going after the first digit. So in this one, 1, 2, 3, 4, 5, 6 space moves apart. So 7, where my new decimal is going to be after the 7. 04. I'm not writing the rest of the zeros because they are not significant. Because remember, I put that green dot there. There was no decimal in the number, so those trailing zeros do not count. And then counting my space moves, remember I had 1, 2, 3, 4, 5, 6. So this becomes 10 to the 6th. And that's a positive exponent because that number is over 1. Now notice here, those end up in the same spot, which means I didn't move my decimal at all. There was 0 space moves. This is a number that doesn't really make sense to put in scientific notation, but it is possible. It's just not one that is kind of for the purpose of scientific notation because it's pretty easy to represent 5, and representing 5 in scientific notation is a little bit more work than not doing it. Here we have 3.04, all of which are sig figs, so I'm going to keep them. New decimal going after the first digit, and then 1, 2 space moves, so times 10 to the 2nd. And lastly, just 1 space move. Again, these are pretty small numbers, so it is not like they're required for scientific notation, but you should still know how to put them in there. Again, keeping sig figs, there was only 1 sig fig, so I'm only putting 5. I'm not putting 5.0 because that 0 should not be considered significant. Okay, moving to the reversal of this, we have numbers that are going to be smaller than 1. So we'll see the opposite. So we're thinking like 99 cents and less. Oh, when you get into really small numbers, it's harder to think of in terms of money. But basically, if it starts with a decimal point and there's no number in the ones place, then we're talking about a negative exponent. So numbers that are smaller than 1 have a negative exponent. Again, thinking about space moves, the difference for these, especially in standard notation, that you will always have a decimal here. So it'll work the same way. The difference being the space moves are going to go opposite because I'm going to make the number smaller. If I go to the right again, the number's going to become bigger. But because it's negative, I need to go 1, 2. So 0.033, keeping my sig figs. One trick here, as well as I showed you above, is because we will always have 1 digit here and we need to get past it, and then the rest become leading zeros. Whatever this exponent is, 1 less than that is how many leading zeros you need. So we have to account for the first kind of swoop, and then the rest becomes 0. So that takes us from 8 to 7, which means I need 7 zeros. So not in counting, I guess, this beginning one, but 7 zeros before the decimal. So 1, 2, 3, 4, 5, 6, 7, 1, 1, 0 to keep my sig figs. And you can see if I did all my swoops here, 1, 2, 3, 4, 5, 6, 7, that'd be, oh, did I count wrong? Maybe. Should be 7. Okay, moving on here to the bottom, we should have our original decimal, and then we're putting our new decimal after that, and then figuring out how many spaces in between. So rewriting this in scientific, we have 1.0043. We have to keep all those because they're significant. And then I only moved one space. But remember, because it's smaller than 1, this is a -1 because it's a small number. New decimal would go after the 9 here. 1, 2, 3, 4 spaces in between. So 9.04 times 10 to the 4th, but that's a -4 because of the fact that there were 4 spaces between, but it is a number smaller than 1. So that is the gist of how I like to go through scientific notation, thinking more about what the value of the number represents and if it should be big or small, if it's negative or positive. Hopefully that helps.